Venugopal. I'm primarily a civil engineer and I went on to do my master's in geoinformatics. So, the primary objective of me coming here is whatever data that your sensors is collecting, most of the data is a location component. So using that location, what are the other things that we can do using geographic information system or remote sensing? How can you supplement your data that you are actually collecting using your sensors with the other data that is already available? What are the data that is available from the various other sources? It can be NRS, ISRO, it can be Karnataka Remote Sensing Application Center. So what are the data that is available? How can you supplement this data and give you some more actual decision making components? So if you see, there are lots of organizations. It can be the government, it can be the market research, construction, couriers. Everybody is doing one common thing, and that is to collect data, and that is the field-based data collection. So sensors are coming up, but even before sensors, everybody is doing this manual method of data collection. They are using a paper-based format where you go to that particular place, list down the attributes of that particular place, have a separate GPS to get your location data and a separate camera to take the photographs. And then you need to come back to the office or the lab, combine all the data and then start making actual decisions. So this whole process is error-prone because somebody who's collecting data on the field is writing something on paper, somebody who's coming here and typing that is not able to exactly correlate, so some other data goes in there. And the whole process is tedious and time-consuming because there is no real-time analysis between the data that is being collected to the data that is coming onto the lab. So our approach was to solve this using again the mobile application because you have your Android phones coming out around 3,500 rupees, 4,000 rupees with good GPS. You have GPS as well as GLONASS as well as Baidu that is helping you to collect data with higher accuracies. So the idea was how can you use your own mobile phone to collect different kinds of data but make it very customizable. So I am doing data for say some kind of a data where I am collecting data about the borewells in a particular village. So I need to have the attributes with respect to that. If I am doing something with respect to construction progress management, my attributes are different. If I am doing something with respect to traffic, I need to collect data about the vehicle density. So everybody's data collection needs are different. Again, we should not depend on a paper-based format to do that. So how can you customize your data collection format, get that onto your mobile phone and collect different kinds of data. It can be a location, audio, video, images, and then send it to a centralized server. From there, you can do the visualizations. So that is what our product Digicollect primarily does. We have done a project for the government of Karnataka. It is called Village Infrastructure Mapping. The primary objective was to map all the borewells in that particular village. So instead of using paper, they did a pilot with our application. So they just gave a smartphone to the data collector, a 5,000 rupees smartphone with a good GPS, and they have the format. The data collector just goes there and says what is the kind of building. Is it a building, a water supply amenity, or a bridge? So once he says water supply, then the questions relating to water supply are going to be shown up. Is it open well, bore well, MWS, PWS, and then he chooses bore well, takes a photograph of that, automatically the location gets attached, and this data along with the other attributes like under which scheme this was financed, is it PMDSY, is it HKDB, is it 505 for REB. So he just selects the data and says what is the condition of the structure and then sends all the data to a centralized server. So once the data is there, this is where we bring the concept of geographic information system. So for those of you who are hearing this for the first time, GIS is nothing but attaching information to a particular location. We have been using Google Maps, so each time you click on a particular point on Google Maps, you are getting some information of that. So it is as simple as getting some information to a location, but GIS is much more. Can you add other layers of data on top of that to help you analyze your data in a much better manner? So I'll just show you one example of how this is being done. So the example that I am going to take now is with respect to real estate. So your location-based analysis can be applied across industries. The example that I am choosing here is for a real estate developer. Suppose he wants to develop 100 acres of land. It can be for a commercial purpose or for a residential purpose. The only thing that he does is go to that particular place, sees the legal records, and then he starts his process of development. But we said, how can you give a multi-criteria kind of a decision-making analysis to a town planner or to a real estate person to develop that particular land? So we considered various factors. We considered factors like distance of that particular land from a settlement, distance from the road, is it a metallic road or unmetal road, distance from the national highway, the snow or the terrain of that particular land, what is the land use, what is the groundwater prospectus in that area, and what is the soil type. So using all these parameters, how can you say which is the best land to invest? So we gave a suitability rating between 0 and 5, 0 being not suitable and 5 being most suitable. And we started getting various levels of data. So this is one data which shows the settlements. Settlements can be villages, it can be towns, or it can be habitats. So where are all the habitats in this particular area? The study area that we took is the Anekal Taluk. So in Anekal, which are all the settlements? And as you move away from the settlements, you are going to get lesser value for your land because the connectivity and also the amenities will not be available. So we said if your land is between 0 to 500 meters of a particular settlement, we give you a higher rating. If it is more than 1 kilometer, we give you a lower rating. So, 10 kilometers, we give you a lower rating. So, one factor was distance from settlement. The second factor was distance from metalled road. So, in real estate, as soon as there is an approach road to your particular property, your value goes up. So, if your property is having the right kind of approach roads, or it's between 0 to 500 meters from a metalled road. Metalled road is the tar or the cement concrete roads, your value goes up. So what we did is we took the data set of all the roads in that particular area, the metal roads and unmetal roads. We did something called as a buffer analysis. So every 500 meter there is a buffer, the next 500 to 2000 meter there is another buffer. So we had another value there also. Similarly, we did there are two national highways passing across Anekal, and again 500 meters from the national highway, 1000 meters from the national highway, 10 kilometers from the national highway, what are the ratings? Similarly, this is the data that we obtained from the Karnataka Remote Sensing Application Center. It is the groundwater prospectus map that they have mapped. Although you are not going to get exact point data in terms of what is the groundwater quality at this particular place, but it will still give you a fair idea of what is the general groundwater availability there. So, automatically the map is classified saying it's very good, we give a rating of 5, then good to nil, we give a rating of 1. If it is already a water body, then you cannot construct anything on top of that, so we give a value of 0. So again, this is another parameter that goes into multi-criteria decision making. Then this data is from the National Remote Sensing Agency. So they do the land use land cover classification for India every 5 years, every 10 years. So they classify the entire India in terms of what is the actual classification in terms of plantations, in terms of land with scrub or forest land, green land, agricultural land, industrial land, built up area. So they have that particular data as well. So again, this was also used as one of the parameters. And again, soil. So again, for construction, soil is going to play a very important role. So we know that gravelly sandy loam soil is good for construction compared to something like a clay soil, where your black cotton soil is again going to expand and shrink based on the water content. So again, based on that particular area, we classified the entire Anekal Taluk with the soil data. Then what we did was to have all these factors. So we have 7 factors, and all these factors, how do you compare one factor with respect to another? So again, that is going to be very dependent on that particular project as well as the evaluator who is doing that project. So when we went and asked some of the prominent real estate developers, they said the major factor for them is the land use land cover. So if it is a green zone, they cannot put a commercial project there. So that is totally out of question. So land use land cover is their first factor, then comes the groundwater potential, then comes their approach road or national highway. So based on the factors, we do a multi-criteria decision making, and finally based on all these things, we get something called as the site suitability map. So in the entire Anekal Taluk, the values between 3.35 and 4.86 on a scale of 5, the red spots are the places where you have the highest potential to do a commercial layout without undergoing difficulties. So the black spots are the ones where you will not be able to go for that kind of a development. So using GIS, using the primary data collected using the mobile phones, we are able to get to a place where you can say this is the best suitability map for something like this. So the idea here is all the data that is collected till now is using your mobile phones or the physical data. Now using sensors, how can you supplement this data and then use GIS to do lots of geo-analytics to help you to visualize them in a better manner, and finally to help decision making. So this is one application that we did for the real estate developer completely on a web-based tool. All the data that is there, including the actual developments that is happening in his site, is able to show it there. So you can say this is the actual water tank in that particular site, and geo-reference the entire project onto the Google Maps and have various kinds of searches. Say you want it by status, show me all the vacant sites. So he'll be able to immediately get an idea of all the vacant sites with the right attributes in terms of what direction it is facing, what is its dimension. So whatever the data that he wants, he'll be able to visualize in a faster manner. And finally, the same thing can be applied to the 3D visualizations as well. So this again for one of the prominent real estate developers to showcase their project in a better manner, to search across floors, to go to a particular floor and then see which is vacant, which is occupied, and then go to its further details. So the reason that I'm showing here is once you have the data, it can be your campus mapping, it can be your hospital mapping where you know what is the location of that particular trip or the campus. You'll be able to model it in 3D, showcase these parameters, show the location of your sensors, and then do some analysis on top of that. So that is the main idea of showcasing how GIS or the visualization technologies can be used to take the data to the common man and show this is what is happening with the data that we have collected. So that is the purpose. Yes. Thank you very much for giving me this opportunity. Any questions?
In terms of, from agricultural standpoint, the quality of the soil or the water levels, the groundwater levels for an acre, was this data that was available? If it was available, what was the granularity of the data? If it wasn't, how did you go about collecting it?
The data that we used is from the Karnataka State Remote Sensing Application Center. So the scale of the mapping is 1:50,000. So 1:50,000 is 1 meter on the ground equals 50,000 meters on the ground. So the data is not very highly accurate on a particular place, but it will give you a general idea of how that particular distribution is there. So what you can do is either using sensors or the actual, either you can do a groundwater data collection or the soil data collection itself. You have the core cutter machine where you can cut the soil and get the actual soil parameters. So you do a series of data collection points and then get the data back into the systems, let's say GIS, and do the data interpolation. And supplement this data with whatever the satellite imagery that is available or the data that is being used by NRSC or the KSR-SAC, and then help you to analyze in a better manner. So the data that we are having is not highly localized, it is just an approximation of a particular flow.
The data you're talking about from various government agencies that have this data, to what extent is that open and has been interfaces to grab it, or you have to take it down at any point and then manage it?
No, I think that is where open data is also playing a very huge role in interfacing with government data vendors, doing that to get lots of these data sets into the public domain. But generally, the data is very difficult to be accessed. Since I was a student in that particular institute, I had an access to that particular data. But even for outsiders, it is very difficult to access this particular data. But things are changing. There is something called National GIS and Karnataka GIS that is coming in. So where they want to put all this data on a public platform and give preferential or an access where the citizens will be able to use it for their projects, but some sensitive data which they don't want to show, they can still hide it. So that is the policy, a very huge policy called National GIS is coming up, where data for all over India, there are lots of data sets that is being created by the National Remote Sensing Agencies, the state application centers. So remote sensing application centers, everybody has lots of data. So that data is going to be on the portal. I think in the coming years we'll have more accessibility to that data as well.
Yeah, that's a good point, because I think right now a lot of the data that the government does generate, the way systems work is that there's taxpayers' money going to generate the data, but it's really can be harnessed for private benefit rather than being public domain. The real estate is a classic case. You have the money to actually access the data and have the pull to get the data. You get it and you can use it for private benefit. So I think that's a very big picture issue that needs to be dealt with in the Indian context.
Any other questions? Thank you very much.